Hey, so we're going to show how to do powers of 10. The real idea here is we're just simplifying exponents. So everything that we're doing with these powers of 10s, we're just following the same rules of simplifying exponents. That being said, we're just going to be working with a base of 10 today since this is a powers of 10 video. All right, so a few things to go over. All right, this is quite useful, being able to change between positive and negative exponents. You can see with this first equation here, if we have 10 to the power of some negative number in the denominator, the bottom of the fraction, then this expression would be equal to writing 10 to the power of a positive x without writing anything like a fraction or anything like that. So that is equal to that. We can say something similar. 1 divided by 10 to the power of positive x would be equal to 10 to the negative x. Okay, so knowing this allows us to put the power of 10 wherever we want, whether we want to move it into the numerator or the denominator, the top or the bottom. All right, we have these two things to discuss as well. All right. What if we have two powers of 10 right next to each other being multiplied by each other? The answer is to add the exponents together. If we have a negative exponent, then we would add that negative number. In other words, like this situation here, 10 to the a power times 10 to the negative b power, that'd be 10 to the power of the answer of a minus b. If we have a situation where we have one exponent on another, then that would result in the two exponents being multiplied. All right. Same thing applies if there's a negative number. You can see that result there. All right. The one last thing to keep in mind has to deal with the number 1, which is anything to the 0th power is equal to 1. So in our examples with a base of 10, 10 to the power of 0 is equal to 1. All right, so for the remainder of this video, we're going to do some examples. All right, the first 4 examples, I'm just going to be showing proof of how these different identities are true. And then we'll do our last example, just solving this crazy looking power of 10 problem here. All right, so for our first example, we wanted to show that 1 over 10 to the minus x is the same thing as 10 to the x. All right. And they gave a suggestion of using x equals 1 to prove this, although we could use anything. All right. So first, let's tackle this problem in the fastest way possible. Let's use a calculator. All right. Let's first set up the problem. So we're going to have 1 over 10 to the negative 1 is equal to 10 to the positive 1. We want to show that this is true. We could type, oh, well, let me just show it again. 10 to the power of negative 1 is 0.1. Okay. So I'm going to rewrite this like that. All right. So we just took this part and we transformed that. Okay. And now let's go ahead and do 1 divided by 0.1. It doesn't matter if you put the 0 or not. I'll leave that for a separate discussion if you're in a 0 camp or no 0 camp. So we get a 10 here. And let's see what 10 to the 1 power is. And we also get a 10. All right, so that's how you just kind of prove that very quickly with the calculator. And just on a kind of personal philosophical note, I am all for doing calculations in your head when you can, when it's factor and makes sense. But that's not to say I don't believe in calculators. Calculators are great for doing quick or routine calculations, and calculators are also great when suddenly your brain feels blank and you just want to verify on a device. Okay. Happens to many of us. All right. Cool. So we prove that to be true. So that being said, though, so that problem's done. But if you want to think about it more like in your head, I do recommend thinking about it that way. Then we could think about it this way. Um, when it comes to working with powers of 10, it might be a good idea to just remember what that power of 10 actually looks like in the first place. So without getting like overly theoretical, um, we can kind of compare powers of 10 versus normal standard numbers. So like 10 to the third power, 3 zeros, right? And that's 1,000. And you can put commas if you like. 10 to the second power, 2 zeros, so that's 100. 10 to the one power, 1 0. And so you can see that we kind of, if we were to like put a decimal point here, we're just shifting it over. We're losing a 0 each time. 10 to the 0 power, no zeros. We have a 1. Sure, put a dot. Why not? All right, so you see that progression, 10 to the negative 1 power then. We're just going to move that decimal point to the other side. And we get a 0.1. Or if you're in the 0 in front of the decimal point camp, 0.1. All right, and we can keep going with this. Oops, I kind of messed up my neat figure here. Whatever. All right. And yeah, I think it's a great idea to be able to generate some powers of 10 from the top of your head. And whenever I'm feeling like stuck or in between, like, oh man, how do I do negative powers of 10 again? I start with something I know really well, and then I just kind of work my way down. And then it's like, oh yeah, that's right. I know how to do math. Again, happens to everybody. All right. Um, so yeah, in this problem, this would have been the useful piece of information. All right. So if we were to like kind of redo it, I'll use this space over here. So we have 1 over 10 to the minus x equals 10 to the x. 1 over 0.1 is equal to 10 to the 1. We also could use that piece of information. We have a 10. And we could bust out our calculator for this, 1 divided by 0.1, but we can also maybe kind of sound it out. 0.1 is 1/10. A tenth fits into 1 10 times. If you have a pizza with 10 slices, each slice is 1/10. You have a total of 10 slices. So yeah, 10 is equal to 10, and we're good. All right, let's keep this going. Example 2. And we're going to show that 1 over 10 over x is equal to 10 to the negative x. And they gave a suggestion of using x equals 2. All right. So 1 over 10 over 2 is equal to 10 to the negative 2 power. This is what we're trying to prove. Okay. 10 to the second power is 100. So we can put that substitution there. I'll try to color code this time. All right. And 10 to the negative 2 power is 0.01. All right. Now we know 0.01 is 1/100th, and 1 divided by 100 is also another way of saying 1/100th. Okay, so 1 divided by 100, 0 is 0.01. 0.01 is 0.1. All right, so we're good there. All right, let's keep this moving. Example 3 was to show this to be true. And Again, we could use anything, but they suggested to us to use a of 3 and a b of 4. Okay. All right, so I'm going to do my work over here. 10 to the third power times 10 to the fourth power. We want to see if that is equal to 10 to the 3 plus 4 power. So 10 to the seventh power. Right? So can we show this to be true? All right, so let's just do the calculator way first. Make sure I'm on the screen. Oh, there we go. No glare. Yeah, I'll do that again. All right, hit equals on that. Once your numbers get big enough or small enough, you might hate to admit it, but you might start liking powers of 10 because there's just so many zeros to write. All right, let's count them. 1, 2, 3, 4, 5, 6, 7 zeros. So I'm going to go 1, 2, 3, 4, 5, 6, 7. All right, put a comma every 3 places. All right, we got 10 million. So is 10 million equal to 10 with to the seventh power? That's going to be 7 zeros, so I like where this is going. But let's just say we are relying on a calculator to verify everything. All right, let's count them. 1, 2, 3, 4, 5, 6, 7. Yep. And as we do any example problem, I encourage you not just to like watch and copy what I do, but to try everything out yourself. The whole point of this is for you to develop your sense of how to do these problems yourself. Okay. Oh yeah. So we're good to go. That is equal to each other. All right, we're good. All right, cool. All right. One more thing I wanted to say is, let's say you didn't have a calculator handy and you wanted to verify this by hand. Again, with powers of 10, I encourage the ability to multiply, or excuse me, write out what that number is as a standard number. You should be able to convert between those two. Okay. So 10 to the third power. We'll just rewrite this. Okay, we're trying to show if this is true. So 10 to the third power, 3 zeros. 10 to the fourth power, 4 zeros. And then 10 to the seventh power, 7 zeros. 4, 5, 6, 7. Okay. And you may remember the old trick. If not, I'll just remind you. When multiplying two different multiples of 10, you can simply add up the zeros. Did I say that right? Multiples of 10. 1 followed by a bunch of zeros. I'm forgetting the name for that right now. But when you're working with some power of 10, yeah, when you're working some power of 10, you just add up the zeros and you're good. 1, 2, 3, 4, 5, 6, 7. And that's 7 as well. So we would end up, yep, it's 7. And that checks out. So again, my story here, feel free to turn powers of 10 into standard numbers if that helps you. Okay, example 4. It may look like a similar problem, but it is different. We have 10 to the a power to the power of b. we're going to use a equals 3 and b equals 4 again. But hopefully you can see here, this is something different than what we were doing here. We're not going to get the same result. We're not going to get 10 to the 7th power. We should be getting something different. Here we added a and b. Here we're multiplying a and b. Okay. Oh, and yeah, we have to show that it's equal to that. Okay. All right, so let's plug and chug 10 to the 3rd, that to the 4th power. And the idea is that's going to be equal to 10 to the power of 3 times 4, which will be 10 to the 12th power. Okay, so that's going to be a 1 followed by 12 zeros. 1, 2, 3. Yeah. 3, 6. Yeah. Okay, we're good. All right. And then here, yeah, 3 times 4. Yeah, so it would end up just being 10 to the 12th power. All right. But you may be wondering, well, will it say the same thing on a calculator for both sides? Let's find out. Let's do 10 to the 3 power. Some calculators, you might have something like this one. I can hit second, and then I hit the log button, which has in yellow 10 to the x above it. That would work similar. If you want to go that way, we could go like that. I'm just going to stick with my usual way. All right. 1 times 10 to the 12. Let's see if that picks up on the camera. That's pretty good. 1 times 10 to the 12. And of course, 1 times anything is that thing. So we don't have to write that. We don't feel like it. And then, so we got that side, and then let's do this side. 10 to the 3 times 4. We're writing it into the calculator a little bit differently. Let's see if it spits out the same answer. And it does. It put out the answer 1 times 10 to the 12th, which is what we had there. And again, for this exercise, we don't need it in scientific notation. If you're like, what's scientific notation? Or that'll be a different video. All right. So good. All right. We've proven a bunch of those identities. Now we can get to that final problem where we're going to have to deal with a bunch of powers of 10. So that was example 5. And let's see. We're going to solve 10 to the 3rd power times 10 to the minus 4, 10 to the 7th power. And then underneath, make that a little longer. We had 10 to the 9th, 10 to the negative 2, 10 to the 1, 10 to the 0. All right. And we're going to solve that. All right. I wrote this problem out to show kind of a variety of different powers of 10. We have a mix of positives and negatives for exponents in both the numerator and the denominator, the top and the bottom. I also threw in a 10 to the 1 power, a 10 to the 0 power to show that that's not going to really make our strategy any different at all. So if I were solving this, if this were me, I wouldn't worry about like trying to simplify as I go along. You may have a few brain cells going off telling you, oh, 10 to the 1 power is 10. I can simplify. Well, you could, as I'll show, that might actually make our life harder trying to like simplify too much at the beginning. I mean, up to you. And then 10 to the 0 power, you may be tempted to say, well, that's a 1. And it is a 1. I mean, I guess you could just cross it out from your expression, knowing that anything multiplied by 1 is that same thing. But even if you left it in there, you're okay. Let me just show you what I mean. All right. But before we go on, I strongly recommend, even if the problem didn't do it, I'm a big fan of parentheses to just kind of remind you to treat these two parts, the top and the bottom, completely separately. All right, so here we go. We're going to have 10, and then we're going to have 3 minus 4 plus 7, whatever that is. And then that's going to be divided by 10. And then we're going to have a 9 minus 2 plus 1 plus 0. Okay. All right, so that's our first simplification. All right, what I'm going to do now is I could type this long thing into the calculator, but that's a lot to type. That's a lot to keep track of. And especially if you have a calculator where you can really do only one operation at a time, that's pretty tough. So I'm going to try to simplify these parentheses at first. So we have 3 minus 4 plus 7. So that should be 6. All right. Let's say you're tired and you can't think. All right, so it's a 6. So we're going to have 10 to the 6th power at the top. All right, and then let's do the bottom. 9 minus 2 is going to be 7 plus 1 is going to be 8. All right, again, let's pretend we're tired. Maybe we actually are. 9 minus 2 plus 1 plus 0. All right, yeah, we get an 8. Sweet. And we get a 10 to the 8th power. Okay. All right, so we have a 10 to the 6 over a 10 to the 8 power. All right, so this is like definitely more simplified than it used to, but we can simplify this further. So if we recall that 10 to the x is the same as 10 to the negative x, we can simplify this further by moving it up to the top, okay, by turning it into the negative version of that exponent. So right now we have 10 to the positive 8. We're going to move it to the top, and that will require us to turn it into 10 to the negative 8. Okay, so let's do that. We're going to have 10 to the 6th power times 10 to the negative 8 power. Now we can use this identity. We're going to add 6 to negative 8. Which is the same thing as saying 6 minus 8. And we're going to get 10 to the negative 2 power. And this one, thankfully, I remember off the top of my head. So I believe that's the answer. And then I'll just close this video showing this long operation in the calculator, and hopefully we get the same answer. All right, so I started a parentheses for the numerator, the top. Let's work on the denominator. So I closed the numerator, the top parentheses, I put a divide, and I'm starting a new parentheses for the bottom. We got it. All right, hope this helps. If you have any questions or anything you want to see or get explained further, feel free to leave a comment. Thanks and have a good day.